Alright, this is section 3.4, graphing lines in standard form. So right here it says, what will you not learn, but rather remember, because you have done this already in middle school as well as in pre-algebra with me. So what you're going to remember to do, and I'm going to explain it to you, is how to graph lines in standard form using intercepts, so that's x and y intercepts, and then graph equations of the form either y equals a number or x equals a number. So here we go. Our first note for this lesson is x and y intercepts. If you have an x-intercept, it's always at the coordinates some number, and then you don't go up or down because you're on the x-axis, so this is always going to be a 0. So y is always going to be 0. The y-coordinate is 0. I'll just save some time here. I'll just say y is 0. Over here for the x-intercept, you don't go left or right, you just go up or down some number to get to a y-intercept because it's on the y-axis. So x is always 0. So x is 0. So again, for an x-intercept, y is 0. For a y-intercept, x is 0. So if you're given an equation and you're asked to find the x-intercept, you just plug in 0 for y because y is always 0 with an x-intercept. If you're asked to find the y-intercept, you plug in 0 for x because x is always 0 for a y-intercept. So here on the first example, it says graph this equation using intercepts. Well, we're going to find both intercepts. So we'll find an x-intercept, use int for intercept, and we'll find a y-intercept. Y-intercept. All right, for the x-intercept, again, if it's an x-intercept, y is 0. So we are going to use 0 in place of y. We're substituting in 0 for y. So we have 8x plus 12y, but now y is going to be a 0, equals 24. So y is 0 if you're finding an x-intercept. 12 times 0 is 0. Anything times 0 is 0. So that just eliminates from my problem. I'm left with 8x equals 24. Divide both sides by 8 and you get x equals 3. So the x-intercept is the point 3, 0. 3, 0, I can graph the point 3, 0. There's my x-intercept. The y-intercept, again with a y-intercept, x is always 0. So I'm going to plug in 0, substitute in 0 for x. So here it was 8 times x, now it's 8 times 0, plus 12y equals 24. 8 times 0 is 0, so that's gone. So I'm left with 12y equals 24. Divide both sides by 12, you get y equals 2. So in this one, 0, 2 is the y-intercept, 0, 2 right here. And then I can draw my line going through those 2 points. Let's see, rise 2, left 3, rise 2, left 3, rise 2, left 3. I'm just making sure I go through all the points that are actually on this line. So I'm just using a constant slope. And there it is. So you always want to put the equation on the line that you use to graph. In this case, I use the standard form equation, 8x plus 12y equals 24. So I'll put that right there. Example number 2, graph this equation. Well, this also is a review from the pre-algebra portion of our year. Graph the equation x equals 7. If you were to make an xy table, input-output table, it says x is 7. X is defined as being 7. You cannot change it because it says right here that x is always equal to 7. So no matter what I try to do, x is going to be a 7. It does not, however, restrict y. Y can be whatever you want. It could be a 1, a 5, a negative 2. It does not matter. Y can be anything you want. It's only defining x as being 7. So 7, 1, 1, 2, 3, 4, 5, 6, 7, 1, 7, 5. 7, negative 2. You have every single point that has an x-coordinate of 7. So if you were to be able to draw every single point with an x-coordinate of 7, ultimately you would end up with a line, a vertical line, and every single x-coordinate is 7. So this is the graph of x equals 7. So if x equals a number, you get a vertical line. This one is not x equals, this is y equals 4. So if you were to draw an xy input-output table for this one, oh, get that back, here we go, an xy table for this one, This one defines y as being 4, so y is stuck at 4. No matter what you input into this equation, a 1, a 5, a 2, it does not matter. 1, 4, 5, 4, 2, 4, 2.74. It doesn't matter. If you graph all the points with a y-coordinate of 4, you end up getting a horizontal line, and that is what I'm going to draw for this one. Y equals 4 is a horizontal line. So if you have y equals a number, you do get a horizontal line. Now this is part of this section, graphing lines in standard form. The last one is ultimately, it is ax plus by equals c. Ax plus by equals c. That is the standard form of a line. In this case, you don't have this term. There's no y, which means b is 0. So it's 1x plus 0y equals 7. It still is in standard form. It just doesn't quite look like it, but it is. It's 0y and a 1x. In this one, it's also in standard form. Ax plus by equals c. In this one, you don't have an ax term, so it's a 0x plus b is just a 1 because there's 1y equals 4. So this also is in standard form. Just doesn't quite look like it at first glance. All right, so here is your assignment, page 133, 2 through 6, 14 through 22 even, and 23 to 24. Because this is ultimately review, I am not going to go through these problems with you. You are responsible for them. I'm not going to work through the problems, I should say, but I am going to just briefly run through them just to help you understand a couple of these. Page 133. All right, so in number 2, it says which point does not belong with the other 3. One of these 4 is not an intercept. 3 of the other points are intercepts, so figure out which one of these is not an intercept. That's the one that does not belong. Moving on, graph the linear equation. These are very similar to those last 2 examples in the lesson. 14 through 22. These problems right here, it says use intercepts to graph. So you're graphing a lot in this assignment, but these are very similar to that first example. Use intercepts, so you plug in 0 for x, you solve for y, and then you plug in 0 for y and you solve for x. So you find both of the intercepts, the x-intercept and the y-intercept, and then you graph using those 2 points. The last 2 are 23 and 24. 23 says a football team has an away game and the bus breaks down. The coaches decide to drive the players to the game in cars and vans. 4 players can ride in each car, 6 players in each van. There are 48 players on the team. They're giving you the equation. So that's all this information. Then they give you the equation. So the equation 4x plus 6y equals 48 is for all of that. And then it says x is the number of cars, y is the number of vans. But ultimately they say graph the equation. So you need to just graph using intercepts, plug in 0 for x, solve for y, plug in 0 for y and solve for x. And then it says interpret the intercepts. So they tell you what x is and they tell you what y is. So in one of the intercepts, x is 0. So if you have 0 cars and then you have so many vans, well, that's interpreting that intercept. And the other one, you have 0 vans and so many cars. And for part B, it says find 4 possible solutions. I'm going to allow you to skip part B. So if you do part B, it tells me you didn't watch this part of the video. You can skip part B on number 23. In 24, it says you are ordering shirts for the math club at your school. Short sleeve shirts cost $10 each and long sleeve are $12 each. You have a budget of $300, but again, they give you the equation. You don't have to set that up. That models the total cost. X is the number of short sleeve shirts and Y is the number of long sleeve shirts. Graph the equation, interpret the intercepts. It's very similar to number 23. So the intercepts, you're going to have one intercept with an X that's a 0, so that means 0 short sleeve and so many long sleeve. And the other one where it has Y is a 0, where that's 0 long sleeve, and then you have to figure out how many short sleeve. All right, so that's your assignment. You can actually, part B here, 12 students decide they want short sleeve shirts. How many long sleeve shirts can you order? So I didn't explain that one yet. So just plug in 12 for the short sleeve shirts, and that is the for X in your equation. Plug in 12 for X and solve for Y. So that's part B. All right, if you have any questions, let me know.